What is deformation? Basically, the property of an object to change its shape permanently when applied force is removed. It means when a force is applied to an object and is then removed, the shape is changed permanently. It means that the shape will not come to its original shape. It means that the object is not elastic. Some examples are hammering of tin can, jumping on the sand, and twisting an aluminium foil. Okay, so now read the definition of the elasticity. The property of an object to return to its original shape when applied force is removed. This is what I taught you about the elasticity. You can also read the examples. Okay, so we are here to understand about the properties of elasticity such as stress. Here the word stress doesn't mean the tension, but stress in physics means something different. The restoring force per unit area offered by surface within elastic limit when applied force is removed. Strain, elongation or extension per unit length offered by applied force within elastic limit. Elastic or breaking limit, limit above which an applied force made a permanent change, deformation in object. Hooke's law is one of the most important law in physics. The statement is that for certain elastic materials, force is proportional to extension when a sample is stretched, or stress in a solid is directly proportional to strain within elastic limit. It means how much you will be extending the solid, the elasticity will extend according to the extension of the material you have extended, such as the spring. You have extend the spring, it will come to its original shape. Until and unless it will not come to its original shape, it is unelastic and the Hooke's law will be wrong. Derivation of Hooke's law is that formula for Hooke's law, force is directly proportional to delta extension, or restoring force is equals to elasticity constant multiplied by extension, and the unit for elasticity constant is K, or Newton per meter. Stress in a solid is directly proportional to strain within elastic limit. This is what we understand. Formula for stress is F upon A, whereas F means force and A means area. Formula for strain is delta L upon L. Formula for area, L multiplied by B. Here the word L means length and B means breadth. By Hooke's law, strain is directly proportional to strain. It means that force upon area is directly proportional to delta length upon length, and force upon area is equals to K delta L upon L, but A is equals to length multiplied by breadth, therefore F upon L multiplied by B means force upon length multiplied by breadth is equals to K delta length upon length. Here finally, the what is the formula basically you are required to understand is written at the last. F is equals to K delta X. It means F is equals to force. And here the word letter X means extension. K means elasticity. This is one of the most fundamental thing in this chapter, and the most students complicate themselves. I do not know why, but these are very simple definitions and the formula you are required to memorize. The definition is torque is a measure of the force that can cause an object to rotate about an axis. Okay. Formula is equals to momentum is equals to force multiplied by perpendicular distance. Now do not complicate yourself that what does mean by the perpendicular distance and what is moment. Tau is equals to F multiplied by D, where the word F means force and D means distance. Now what is equilibrium in moment? Now word equilibrium means something like balance or equal. A statement is when total clockwise moment equates the total anti-clockwise moment. It means that it is now in equilibrium in moment. The formula is anti-clockwise is equals to clockwise. It means the value of clockwise moment which is in negative and anti-clockwise moment which is taken in positive must be same. And once they are same, they are in equilibrium. Now understand the types of equilibrium. The stable equilibrium. If a body in equilibrium is disturbed and it comes back to original position, it means that it is stable equilibrium. If a body in equilibrium is disturbed, it does not come back to original position but its direction is Predictable. It means that it is unstable equilibrium. If a body in equilibrium is disturbed, neither it comes back to original position nor its direction of motion predictable. It means that it is neutral equilibrium. Two states of equilibrium. Static equilibrium. If an object is in equilibrium and rests at its position, it is said to be static equilibrium. Such examples are a book resting on a table, a wall clock hanging on a wall, and a dynamic equilibrium. If an object is in equilibrium and is moving with constant speed, it is said to be dynamic equilibrium, such as a pendulum moving in a clock, the earth revolving around a sun. Stability and center of stability. Stability is an ability of object to return to its original position after it is slightly disturbed. Center of stability. The point at which an object is being managed to balance its equilibrium. Stability and types of equilibrium. Stable equilibrium means if the center of gravity is within the base of object, it remains in stable equilibrium. Lower the center of gravity, more stable the object is. Unstable equilibrium. If the center of gravity is at the base of object, it is unstable equilibrium. Higher the center of gravity, more unstable the object is.